All right, 7.5, solving square root and other radical equations. So starting off, what is a radical equation? A radical equation that's an equation that has a variable in the radical or a fractional exponent. So we'll say an equation with a number in the radical or with a fractional exponents. We have special radical equations. We'll say the square root equation or something that falls in the category of a square root equation. Well, that's a radical equation. Only the radical has to have a 2, or the exponent has to have a 2. I'm not going to write that down because I think that's pretty self-evident. So these have a special technique to solve them, and let's go on and look at example number 1. Number 1, we're going to have 2 plus the square root of 3x minus 2, and that's going to be equal to 6. Now what's different here, and how this is probably new to anything you've done before, the variable is under the root, and it's not alone. There's other stuff under the root. So to start off, we're going to need to get that root all by itself, right? We're going to want to square this to get rid of the root. To begin with, our root needs to be by itself. So I'm going to subtract 2 from both sides, and I'm going to have root 3x minus 2 equals 4. Now, to get rid of my root, I'm going to take the whole thing, and I'm going to square it. Some people like to write it like this. I normally like to just say, oh, I'm squaring the whole thing, and I know what I mean by that. So whenever we square and we root, they cancel out, and I'm just going to be left with root 3x. I just said the root goes away, but then I wrote it. So 3x minus 2, and then 4 squared will be 16. Now we solve it just like any other, what is this, a two-step linear equation. So we add the 2 over, and then we'll have 3x is 18, and x is 6. That's that. Let's do a couple more of these. Number 2, we're going to have, what are we going to have? Negative 10 plus root 2x plus 1 equals negative 5. So just like last time, and just like all of these, you're going to start off by getting your root alone, right? Just like how normally you'd solve and get your variable alone, well, we're getting the root alone. We add our 10 over, and we'll be left with root 2x plus 1 is 5. Now we're going to square everything to get rid of our root, so we'll have 2x plus 1 is 25. 2x is 24, and x is 12. All right, example number 3. We're going to have 2 times the quantity x plus 3 to the 3 halves equals 54. This one still falls in the category of a radical equation, right? Because we have a radical there. It's just disguised as a fraction, as a fractional exponent. These, I think, look scarier, but they're still just as easy. We're going to need to start off by getting our parenthesis stuff alone. So we're going to divide everything by 2. So then we'll be left with x plus 3 to the 3 halves is 54. Now, what changes here, and what makes it just a little bit different than the last one, is we have that fractional exponent. we want to get rid of the whole fractional exponent. We don't just want to get rid of that 2 that's part of the root. We want to get rid of the whole thing. So what I'm going to do is I'm going to multiply the whole thing by 2 over 3, or raise it to the power of 2 over 3. Oops, I'm sorry. I wrote 54 here. We should have a 27. I'm sorry. Right, we get that from dividing the 54 by 2. All right, moving on, we have the 3 halves and the 2/3. Well, those just cancel each other out. So we have x plus 3, and then we have 27 to the 2/3. Well, that 3 in the bottom says we're taking the cubed root of 27, and there is a cubed root of 27. It is 3, so we're going to have 3 squared. Now we can say we have x plus 3 is 9, and x is 6. All right. Next up, we have a new idea. Sometimes whenever we square or we root equations, we end up ruining part of the equation. And it's not really ruined, but we get extraneous solutions. We get solutions that don't actually work. Extraneous solutions. So we'll say these are solutions generated when raising both sides of the equation to a power that do not solve the original. All right, so extraneous solutions are solutions generated when raising both sides of the equation to a power that do not solve the original equation. All right, so they're bad solutions. You end up getting an x equals, but whenever you plug that back in, it doesn't work. It doesn't solve it. So what's going to happen next is we're going to continue solving them like what we were in the previous examples, but we're going to, at the end, we're going to have to check. Well, were there extraneous solutions? Is there a bad solution there? So let's look at number 4 here. Example number 4, we're going to have root x minus 3 plus 5 equals x. Now this one you can see here is a little bit more complicated than last time because we have 2 x's in there. It's not just the root that's under the x that's underneath the root, but we have the x that's not underneath the root also. Just like last time, we're going to try to get our root by itself. So I'll have root x minus 3 is x minus 5. Well now, just like what you'd expect, we're going to square this. So the left side gets squared, the right side gets squared. So the left side turns into x minus 3. Whenever we square the right side, it's going to turn into x squared minus 10x plus 25. Now these equations we should know how to solve. It's a quadratic equation, and to be able to solve the quadratic, we normally like to get one side of it equal to 0. To keep my quadratic term, my x squared term positive, I'm going to add everything or subtract everything to the right side. So how 0 equals x squared, then I subtract an x, so it'll be 11x minus 11x plus 25, 26, 27, 28. Now, if you remember correctly, we need 2 numbers that multiply to 28 and add to be negative 11. So normally I like to do a little factor tree here and find what can I multiply to be 28 and add up to be 11. 2 things that multiply to 28 are 7 and 4. And we want them to be negative 11 or add up to negative 11, so I'm going to make them both negative. So whenever I factor this, it'll be, well, 0 equals x minus 7, x minus 4. This means that 0 equals x minus 7 or 0 equals x minus 4. Oops, I put an x there. That should be a 0. So x is 7 or x is 4. Now, we have to check for an extraneous solution, right? And I'll tell you now, one of these two is not going to work when we plug it back in. So we're going to plug it back into our original idea, our original root. So I'm going to say, well, root 7 minus 3 plus 5 equals 7. So this is going to be root 4 plus 5 is 7. So 2 plus 5 is 7. Well, that's good. So x equals 7 is a good answer. Now for 4, we're going to have root 4 minus 3 plus 5 is 4. So this is root 1 plus 5 is 4. So 1 plus 5 is 4. Well, that's not true. So x equals 4 is not a good answer, right? Now what happened there is whenever we squared them, we ended up creating a second term, or creating a second answer. And we had to go back and we had to check, well, is that a good answer? And it was not. All right, moving on to example number 5. We've got root 3x plus 2 minus root 2x plus 7 equals 0. This one, again, is a little bit more complicated than the last one even. We have two different roots. To begin here, we're going to try to get each of our roots alone. So I'm going to add my negative root to the other side, so then I'll have root 3x plus 2 equals root 2x plus 7. I'm going to square both of these to get rid of my roots. So I'll have 3x plus 2 is 2x plus 7, so x is 5. Now, we still need to check for extraneous solutions. Even if you only have one solution, you still need to check it, because it could be that there's no real solution to it. So plugging this back in, I'm going to say I have root 3 times 5 plus 2 minus root 2 times 5 plus 7 is 0. All right, I'm plugging back into the original problem. So this is going to be root 15 plus 2 minus root 10 plus 7 is 0. This is root 17 minus root 17 is 0. So that's good. That checks out. And that's our answer. All right. All of the homework works the same way. You're doing the same general process, even on the ones that we did 1 through 3, where we didn't check for extraneous solutions. But on the homework, you're going to need to check for the extraneous solutions. All right, that's all.